Hi, I'm Carl Franklin. In this episode of Blazor Train, I'll show you some code I've recently shared that lets you query a repository from the client side, serializing the query, passing it to the server side where it's deserialized, so a small subset of records can be sent back to the client. This is stuff you've probably written custom code for on both client and server 100 times, maybe 1,000,000 times, I don't know. But now you can avoid all that and write it once. I've modified my now infamous iRepository interface to handle querying, and I'm going to show you how to use it on the server for an in-memory repository, an entity framework repository, and a Dapper repository, as well as an API repository on the client for making the calls. Using a Queryable repository is coming up right now, right here on Blazor Train. So we're starting with a library that I created called AVN Repository. It's on GitHub, it's public, and the whole idea is I took all the classes, including the iRepository interface that I've been using, and I moved them all into this library. So you can include this in any project where you want to use the repository. So I've got the API entity response, the API list of entity response. Now, I've talked about those in previous episodes of Blazor Train where we were doing anything with repositories. Here's my updated iRepository. This is going to use a new class called QueryFilter. And QueryFilter is quite awesome. I'll show that to you in Visual Studio. But the whole idea is that I couldn't figure out how to serialize a link expression, with included properties and order by to send to the server. And listen, I tried everything. I tried projects out there on GitHub that were supposed to address this problem, and none of them worked, quite frankly. And so I just resigned myself to create a new class called QueryFilter of tEntity that has all of that stuff in it, but not using link at all. So the Blazor repository demo is the demo that I'm showing off today. Now this uses AVN Repository, but it uses it as a NuGet package. Now I'm not going to go through all the steps to build the demo because, quite frankly, they're outlined here. Like, you can follow these instructions. I know that's scrolling by really fast. But if you follow all the instructions, you'll be able to end up with exactly what I have right here. The only difference is that I've included the AVN repository project as a project instead of a NuGet package so that we can actually go look into them. So we're going to create 4 repositories, 3 on the server and 1 on the client. The one on the client abstracts all the API calls with HTTP client, and the 3 on the server are in-memory, entity framework, and Dapper. They're all going to be using this class customer. Now, the reason that I have these attributes here is because I'm using this thing with Dapper called Dapper Contrib. And Dapper Contrib is a library of contributions that make it easy for us to do inserts, deletes, and updates and selects, but also have these attributes that it needs in order to figure things out. For example, which property is the primary key? And the key attribute says not only is this the primary key, but that it's an identity column, meaning that you supply a key of 0 when you insert a customer, and then that gets filled in by the data store. And that's the case with Dapper and Entity Framework because those are both looking at SQL Server. The in-memory repository is just going to ignore that. Also, you'll notice the table attribute. The reason I need that is because Dapper Contrib assumes that the table name will be a pluralization of the entity name. So it's going to assume that it's customers unless you specify otherwise. Now, the iRepository interface is part of AVN Repository, so that's the namespace. And this is what's new here. Now, I've shown delete, delete by ID, delete all, get by ID, insert, and update. I've shown those before. And I also had a sort of a link expression version of this. And that's fine if it's on the server, but if it's not on the server, if it's on the client, now we got problems. So I created this query filter, and that's what I want to show you now. So it's a serializable filter. It's an alternative to trying to serialize and deserialize link expressions, which are very finicky. In other words, I couldn't figure it out, and none of my friends could either. So here's what we have. A list of string of property names that you want to include. So this is like your select clause. By default, all the columns are returned, but if you want only name and email without the ID, for example, or if you only want name, you can specify those here. Next is filter property, which is in the where clause. We'll come back to that in a second. The order by property name. So if I want to order by ID or name or email address or whatever, and then we have a Boolean order by descending, which tells us whether we want the result to be descending or not. All right, so filter properties. Let's look at the filter property class. So filter property defines a property for the where clause, and you can have more than one of these. Where this column equals that or does not equal that, or begins with or ends with or whatever. So it includes a name, that's the property name, the value, which is a string. It's a string because this is most likely going to be used on a client where it needs to be serialized and sent over the wire, and therefore everything's going to end up as a string anyway. So we have a string representation of the value. Then we have a filter operator, which is an enum, which is begins with, ends with, equals, not equals, less than, greater than, less than or equal, greater than or equal, that kind of stuff. And then whether this comparison is case sensitive, and the default is false. So just for clarity, let's look at the filter operator enum, exactly what I said. Now built into query filter is this method, getFilteredListAsync. Now you don't have to use this, but it's very handy. You pass in a list of all items, could be IEnumerable, I could probably make that a little bit better. And we get an iQueryable from that, and then we're going to create an expression of tEntity bool. This is essentially the link expression that we're going to build up. Then we go through each property, and we use some reflection to get the property info, which then we can look at the type. Now for each built-in value type, string is a reference type, but we're treating it as value type here, we have different processing for. So for a string, we're looking at the operator, and if it's equals, we're going to do an equals comparison. And if it's not equal, we're going to do a not equal comparison. See what I'm doing here? And starts with and ends with and contains, and so on. Now this is an expression. So essentially what I'm doing is saying, hey, if, let's say, equals, if in this expression the item has a property value to string to lower equal to the value to string to lower, then they are equal. And that's if case sensitive is false. If it is case sensitive, we don't convert them to lowercase first. Okay, so that's strings, all the strings. Now we have processing for int 16, for int 32, int 64, unsigned integer 16-bit, unsigned 32-bit integer, unsigned 64-bit integer, date time, decimal, single. Hey, where's double? Double's missing. I got to fix that. Boolean and byte. Oh, and char. So if you have your own types that you want to compare, you can just add processing for those there. And then that expression is added to the where clause. And then we're going to include the specified properties, if they are specified, with the include method on the iQueryable. And then finally, with the order by, we can apply that either descending or not. And finally, we return query to list, and everything's done. Now, the downside of this whole thing is that you have to specify all the items. So if you already have all the items in memory, great. But if you don't, you're going to have to do some extra work. Now, in the Dapper repository, I have showed you how to create SQL statements, custom SQL statements with select for Dapper the entity framework and the in-memory repositories use this method, so they require all the items, but the Dapper repository actually does a little bit more work for you and is therefore more efficient. All right, so getting back to the Solution Explorer, we've got our model, we've got our repositories, we've got our AVN repository stuff, all that goo. I've added a reference to AVN repository in the client and the server. So on the server, let's look at memory repository. Now I've shown you this in all of the other repository demos that I've done, but just to show you that I've added this method here, getAsync, with a query filter of tEntity. And look, all I'm doing is getting all the items and returning that query filter's getFilteredListAsync. So pretty easy for the in-memory repository. Now I've created a controller for the in-memory repository, and I'm injecting memory repository of customer so that I have all the standard stuff that I showed before, and I've added this getWith filter that passes that query filter, very easily serializable. So I call getAsync with the filter on the customer's manager and just return the data. On the server, I've had to add this guy. Add singleton memory repository of customer with a new memory repository of customer, and ID is specified as the primary key. The memory repository has to know what the primary key is, or the ID property, because it's doing some reflection in order to get that to work. On the client, just as before, we've added this API repository of tEntity. And this is an implementation of iRepository that uses an HTTP client to do the calls with JSON to the controller. And check this out. Here's the query filter call. So no big deal there. Yeah, we have it as a post because we need to pass a complex type. Now here's an implementation of that for the API. Customer repository. So this is a custom implementation just for the customer entity. And look, I can pick which one of my controllers I want to call. Otherwise, it's all the same. And this is the whole class right here. Isn't that crazy? So this time I'm going to call in-memory customers. And if we look in program, we just need to add customer repository as the scope service. Now I've done all my imports and my usings and all that. So if you look in the client in index razor, here's what we have. We're injecting a customer repository. I'm calling it customer manager. And I've got some standard stuff that you've probably seen before, but now I've added search capabilities. Well, let me just show you. All right, so here I've got 4 items that I've added in memory, and in the initialization, I've created these customer objects and I've sent them up. So now I have, I can update, watch Isadora here. All right, that just got changed. I can delete a couple of guys. I can use get by ID. And you can see retrieve Jenny via ID 3 right there. But now, if I reset, I can also do a search by last name. Let's search for starts with R. All right, here's starts with. I have case sensitive and I have descending order. So let's do case insensitive first. But if I go case sensitive, guess what? Nothing. Now I'll reset the data. I don't really need to do that, but let's search for the customer with a last name, or the name, actually there's no last name, where the name contains the letter O. All right, so now I've got Isadora Jar, Jenny Jones, and Rocky Roads. All their names include O. If I specify descending, now it's 231 instead of 132. And if it's case sensitive, no problem. But if I use yep, there you go. All right, so that's pretty cool, and that's all just in memory. But here's the thing, all of this code is going to work no matter what repository we're using. That's the beauty of this. All right, so you can see down in Add Customers that gets called initially. I'm inserting those 4 records. All right, to the search. We're creating a new query filter of customer. We're adding the filter properties. Remember, this is the where clause. We're adding one property here. It's the name property. The value is the search filter, which comes from that input. The operator is the filter option, which comes from the select, starts with, ends with, or contains. And then the case sensitive is that checkbox that I created. So you can see here are my options. Case sensitive, descending, right? My input is bound to search filter. When you click on a filter, if it starts with, then I set the filter option to starts with, etc., etc. So then I have the order by property as name, and the descending is that descending flag. So this is also bound to a checkbox, descending. See? Easy. Now here's another example of searching. This time we'll search by ID, which is an int. And we want where the value is 2, and the operator is going to be equals. Right? So we're searching for ID of 2, which, if you look in my initial creation here, should be Rocky Roads. So now when I press that button, it's not going to use any of those inputs. It's just going to return Rocky Roads because we're searching by the ID of 2. And there you go. There's Rocky. Now the last demo searches where all the IDs are greater than 1. Okay, so the filter operator is greater than, the value is 1, and we're searching on ID again. Here we go. Great, 2, 3, and 4. How about in descending order? There you go. So I'll do a demo using the Entity Framework repository. I've created this database right here, repository demo, and the instructions are actually in the document here. It's called repository demo, and it's got a customer table with a primary key ID and the name and the email. In the server data folder, I've got a repository demo context that inherits from DB context, and I got all this by scaffolding, and the scaffold command is also in the documentation. One thing to note that if you do scaffold, it's going to create another customer CS file in this data folder that you have to delete. So here's my EF repository, and this takes 2 generics, tEntity and tDataContext. So we have an entity type and a data context type. And I believe I showed this before. The only thing that I didn't show is the query filter. So again, we have to get all the items. Otherwise, you're creating SQL statements in here. And we're going to do that in Dapper because we can. But right here in Entity Framework, you're getting all the items and then filtering them down. So caveat, be aware of that. Also created an EF customers controller, right, which passes in the EF repository. And again, it's otherwise the same. Here's my query filter. And in program, we add it with these 2 guys. First of all, we're adding the repository demo context, which is my DB context, and then the EF repository using that context. Now on the client, all we have to do is change the controller name to EF customers. All right, now just to prove that we're actually changing data, I'm going to right-click on the customer table and view the data so you can see the name and email addresses of the people that we have in here. So notice Isadora Jar, we're going to change that right now. There you go. And I'll update this data and boom, IsadoraJar.com. All right, let's do a filter. So we're going to do something that starts with H. Yes. Let's do something that ends with S. Okay, good. How about contains O? How about contains a capital O? Still the same because it's not case sensitive. Turn on case sensitivity. Oops. Now how about descending order? Yes. All right, so all that stuff is there. Let's delete Rocky and Hugh. Go back here and refresh the data, and poof, they're gone. If I reset the data, now they're all back again. Now let's talk about Dapper. Well, it's kind of the same stuff. I've added to the server project Dapper, Dapper contrib, and system data SQL client. I have a Dapper repository here, which is an implementation of iRepository of Entity, same kind of stuff. And this one, I did a Dapper demo that you could probably go back and look at if you want the details of how Dapper works with the repository. So I'm going to focus on this guy right here, the query filter. So I have a query filter, and instead of getting all, I'm constructing a SQL select string, such as from products where product ID equals blah, blah, blah. I put that there as a guide. So I'm creating a select string by concatenating. And before you accuse me of propagating SQL injection attacks, know that all of, even SQL statements, all of Dapper can use parameters. So that's what we're doing. We're creating parameters. I'm creating a new dynamic parameters from a dictionary where I added the filter properties, name and value. Okay, and that's just this dynamic parameters is going to get added when we execute. So now we can use those parameters with @ in the name. So what I'm doing here now is going through the included properties. And if I have included properties, I'm only going to add those property names. Otherwise, I'm going to select star, all properties. So here's my from clause. I'm going to add from entity name. And now I'm going through my dictionary. So this is the where clause, the filtered properties, right? So you can see what I'm doing here. If the filter operator is equals, I'm saying key equals @key. Remember, this is the parameter, right? So there's no way that a SQL injection could happen here. Not equals, I have a not equal key. I have starts with, I'm using like, key plus %, ends with % plus key, contains, like % plus key plus %. Less than or equal, greater than or equal, right? So very, very easy to do that. And here's one. Here's a trick you might not know about doing case-sensitive queries in SQL Server. But if you add right here collate and Latin1_general_CS_AS, it does a case-sensitive compare. If there are more properties in the where clause, we say and then we go through again till we're done. And now the order by property name, and if it's order by descending, we add the keyword desk. So remember what I said about parameters? Here it is. Await DB query async of T entity, pass the SQL string and the parameters, and return the result. So in case you haven't picked up on it, I really like Dapper because you can do stuff like this. And imagine you've got a database just, with thousands, millions of rows. You don't want to query all just to filter it down. You want to do a specific query just for those things. And that's what this code does. Now the controller is pretty much like every other controller. For my get with filter, I'm passing, the query filter, a filter, and I'm just calling customer manager get async filter. So I don't have to get all. And in the server, we add it like so. Add transient Dapper repository of customer, passing a new Dapper repository of customer with the connection string that we get from configuration, which I didn't mention. I've added that connection string, repository demo connection string. to my app settings. Now all we have to do on the client is change this. And we're calling another controller. There we are. We can update Isadora, delete Rocky, delete Hugh, and go check the data again. Refresh. There you go. Isadora is updated. Rocky and Hugh are gone. And we can reset the data to put them back. Let's do a search by last name, starting with I. Case sensitive should return nothing. Yes, it does. How about ends with S? How about contains O? And just for fun, descending order. There you go. So this is a very, very flexible architecture, I believe. And this query filter, it's a good start. I'm hoping that I get some pull requests from you and some of the other passengers so that we can really max this thing out and get it working right. Just a note, since I recorded this demo, I've cleaned up a few things in Query Filter. The string comparison is a lot cleaner. I've added handling for double precision values. I've changed get filtered list async to non-async because there were no asynchronous operations in the code. And I also changed list to IEnumerable. And there's another thing I'd like you to know about. DevExpress has a brand new data grid that has this feature built in. It's called Queryable as HTTP service. And it uses this data source loader class that you implement on the API side. And then the grid can pass all the sorting, filtering, and other property values of the grid right to your API endpoint, which can then do a filtered query. I just thought you'd like to know. Now back to you in the studio, Carl. In case you missed the GitHub URL to the repository demo, here it is. As I said, the README file walks you through creating this code step by step. I'd suggest you bring your own coffee, though. Hey, thanks for riding the rails with me today. I'll see you next time. Because, you know, this is where I jump off and all that stuff. I think I said that backwards, but you know what I'm saying. Blaze the train!